Hello and welcome. This is a video that sort of introduces or provides an overview to the topic of inventory for the introduction to operations management. In this video we talk a little bit about the concepts of why inventory is important. Towards the end of it we will talk about some fixed period models and that sort of thing that we don't spend a lot of time, that I generally don't spend a lot of time on in an operations management class. I have a separate video where I introduce the concepts of the economic order quantity, the production order quantity, and the quantity discount model. Again, in separate videos, I show examples how to do the EOQ, the news vendor, which is a single period inventory model, the production order quantity, quantity discount model, variable demand, so with safety stock and incorporating variability, and a couple of other ones. But this one really is intended to provide an overview of inventory and why we study inventory at all. And the first question then is, why do we care about inventory? Well, the easy answer to that is that inventory costs money. Inventory are products that we hold at various stages of production, and while inventory matters a little bit in the service industry, this is probably the topic that has the most direct relevance to exclusively to product manufacturing, product distribution, and we're going to spend a little less time on service in this section. But so we care about inventory because inventory costs us money. And so the next obvious question, well, if it costs us money, why don't we hold less of it? And the trade-off on inventory is the cost of inventory versus the customer service level. We know that inventory helps sell products. We know that if we have unpredictable demand, we want to have inventory so that if someone comes in to buy something, we have that and we don't lose that customer. So inventory strategy is about balancing inventory cost with customer service levels. And, you know, if we think about it, inventory is probably one of the most expensive assets of many companies, representing as much of total as 50% of total invested capital. So inventory matters, and if we can control the costs of those inventories and still deliver a good customer experience, we can improve our bottom line. Excuse me. And it is the role of operations managers to balance that inventory investment and customer service. And so that's one of the key roles that you as future managers in a variety of roles will play. So let's talk about Amazon. I mean, when Amazon first started, it was a virtual retailer. It held absolutely no inventory. That's different now, and really they provided a facilitation function. They brought sellers and buyers together and then dispatched, so they had really no cost. Growth allowed, it says here, forced Amazon to become a world leader in warehousing and inventory management. What they started to do was to take ownership of some product, own some inventory, own distribution systems to improve A, their customer service levels, and B, their margins. You know, if you hold the inventory and buy the products and then resell the products, you make more margin on that exchange than if you are just bringing a buyer and seller together. So as Amazon grew into the company that we've seen today, they became a world leader in managing both warehousing and inventory. And if you look at what they do, and this is constantly evolving, each order is assigned by a computer to the closest distribution center. So you go online, whether you're a Prime member or a regular member, you place an order. That order is dispatched to the distribution center that minimizes the logistics cost of getting it to you while still having the product or products together. Often on Amazon you get a choice of whether you want them shipped together or shipped separately. And then in those warehouses, they're either picked by hand or picked by computer or by robots and then are aggregated, and items are placed in crates on a conveyor. Barcode scanners scan each item 15 times to virtually eliminate errors. This isn't unique to Amazon. Sobeys has a new system, their Voila system, which delivers groceries, and they can pick a 50-item order in their robotic warehouse in Vaughan in 5 minutes. Whereas if you're picking an order of 50 items in a grocery store, like we often see now, that takes 50 minutes or 60 minutes. And so we see that there is some real incentive to not only doing a good job on distribution, but on making sure we have inventory there. One of the biggest complaints that food companies have had is that items in stores are running out, so that they're not picked correctly. They're either not substituted or substituted with something that customers don't want. So inventory matters, again, not just from a cost perspective, but from the perspective of making sure customers are getting what they want. And there are several steps in that distribution system. So the objective of inventory management is to strike that balance between investment and cost and customer service. So why do we have inventory? Well, inventory not only at the customer interface makes sure that we can deliver products when they want, but inventory can serve several functions throughout the production process. And it says here to decouple or separate various parts of the production process. So it provides a buffer so that if one system or one part of the system breaks down or has problems, the next part of the system can continue to run. So if there are different processing rates or different maintenance schedules, inventory allows that process to continue to work while those disruptions occur. It can also help us protect us from fluctuations in demand, so that we have inventory in case there's a spike in demand, and it allows us to provide a level of service that keeps customers coming back to us. If they depend on us having it, and we don't always know how much we need, we have inventory in order that we can meet those demands. We sometimes get inventory to take advantage of quantity discounts, and we'll talk less in this video and other videos about how we decide whether to take advantage of quantity discounts. And also sometimes, less so in the developed world, but in countries where hyperinflation, inventory helps us buffer against the significant appreciation in cost, particularly if we're selling into the future. So lots of different types of inventory, and these will make a lot of sense. There's raw material, purchased but not processed. So at the beginning of a process, of a production process, there's work in process that's undergone some change but isn't finished at various stages of the production process. There's what's called maintenance, repair, operating inventory, and it's really supporting inventory, but it's stuff that helps us to ensure that our process can keep working. So it's not a direct input into the process, but it is inventory that we hold to make sure that that we can continue to operate. And then we have finished goods inventory, and depending on what kind of organization, if we're a manufacturer, we have stuff that's being ready to be shipped to distribution or to retail or whatever. And if we're a retailer, we have finished goods that are ready to go, that are ready to be picked out by customers, either directly or to be picked and shipped, depending on what type of organization we are. So there really are inventory at all stages. And this really sort of articulates a little bit why we need that inventory. Is there are lots of, in the material flow cycle, and this is just a timber mill as an example, there are all sorts of different steps, 95% of it that's not productive, that we need to have inventory to allow us to make sure that at all stages we have stuff ready to go that allows us to continue the process moving forward. So if there's a breakdown here, then there is still output ready to go to customers, and if there's a disruption at another stage, we continue to have product ready to go so that the whole process is not disrupted. So it becomes a real buffer in that process. So that's why inventory matters. That's why we think about it. There are a variety of ways of managing inventory, thinking about how much inventory to hold, thinking about where to hold it. We often classify inventory in a variety of ways in order for us to think about where we should think most about managing. We should think about all inventory, but some is clearly more important than others. And then we talk about keeping accurate inventory records. So one approach is really quite simple. It's called ABC analysis. And ABC analysis divides inventory into three classes based on annual dollar volume. So class A is high annual dollar volume. So that can be lots of product that's not very expensive, but as a whole it's high value, or small volumes at high prices. The things that cost us the most we pay more attention to. So we have those class A, then we have class B and class C. So this just allows us to say we should manage everything, but we should pay the most attention to stuff that is in class A. We establish policies that focus on the few critical parts and spend a little less time on the many trivial ones. So how do we do it? Well, this is a simple example. We have sort of here on the left stock item numbers, and we talk about percentage stocked, we talk about annual volume, we talk about unit cost. So then we have an annual dollar volume, and then we can total it for all and then see that in this circumstance, you'll see on the next slide, 90,000 represents almost 40% of the dollar volume of the stock items we've stocked. So this is clearly something that matters. Here we have another item that we usually have a 500 volume in 500 units that we use in a year. It's more expensive, so it's 77,000. So you can see some things are big numbers, smaller unit cost. Some things are smaller numbers, bigger unit cost, but they represent big percentages of the annual dollar volume. So the breaks between A, B, and C are relatively arbitrary. Here you see kind of a natural break. We go from about a third down to 11%. So that break makes some sense. Here we have, again, big volume, low price, low volume, low price. All of these represent lower percentages of our total dollar volume. And then again, this is 72%. The specific cut line is relatively subjective, but you look for logical breaks, sort of big chunks, and that's how you establish that ABC analysis. And then here we have C, low cost and or low volume, that represent a very low proportion of our total. So we should be paying attention to them, but really, if we can save money on those A products, we're going to make a bigger difference. So ABC is just a way of prioritizing. We multiply annual volume times unit cost to get a percentage of the total annual volume, and then set priorities for managing inventory. So that's a very simple way. There are other ways that you can, other things that you can think about, and you can graph the percentage of dollar and percentage of items. So the A items were only about 15% of the total, but they were represented a significant chunk. B items were a bigger chunk of the items, but a very much smaller chunk of the of the cost, and the C items, again, lots of them, but represent not very much. So it's just a graphical presentation of the same thing. ABC is a simple way. It's one of the common ways that we sort of classify inventory, but there are others, and you will read those in any standard operations book. As I said, you might use different criteria as well. You can use anticipated engineering changes. So we'll want to watch inventory of things where that is going to change. And so we don't want to have too much of that inventory if the new product is going to become available, particularly if we are changing our processes, and this is an input into that process. We don't want to have excess that we then have to discard. We can consider delivery problems, even if it's not a high value product. If delivery is uncertain or unpredictable, then maybe we move that up in classification. Quality problems as well. We might get it regularly, but we have to write off half of it. And again, we'll pay more attention to that inventory. And high unit costs. Sometimes, even if it's not a big percentage, if each individual item costs us a lot, we'll move that up from C to B or from B to A, just because we're worried about if we lose one item, it's a significant cost. So ABC analysis has some objectivity, but also some subjectivity, and it really just provides a way for us to prioritize inventory to pay attention to. And prioritizing means more emphasis on supplier development, so we have suppliers that we know and trust and have a relationship with. We might pay more attention to the inventory of A items, and we'll pay more attention to forecasting of A items, because again, in this case, forecasting errors, either too much or too little, will cost us more money than it will at other stages of the production, or at other classes of inventory. So let's switch now and talk a little bit about recording inventory. You know, it's important that we have accurate records, because if we don't have accurate records, we won't know when to order. Inventory control is based on the foundation of a good understanding of what our inventory is, and otherwise all of the other tools are relatively useless. And then it allows us as an organization to focus on what we need. It's necessary to make precise decisions about ordering, scheduling, and shipping, and we can't make those precise decisions if we don't know what we have and have a good understanding of what we need. Incoming and outgoing record keeping must be accurate. Again, it's important we know what we have. If we don't log stuff in, then we might order unnecessarily. If we don't log stuff out, we might run out. And so understanding that becomes pretty important. And we count inventory. Items are counted and records updated on a periodic basis. Even if we have automated systems where everything is scanned in and out, and we have when I worked in industry, we had a system that had a automatic inventory control based on what we used, but we still did a monthly actual count to make sure that stuff wasn't disappearing, shrinkage, we weren't losing stuff to theft, there weren't mistakes, and it allowed us to make sure that we didn't run into trouble because of a systems flaw. And we often use, again, ABC analysis to determine cycles. So the A stuff might get a daily inventory count, the B a weekly, and C a monthly. So we can do all sorts of things, but it's important for us to be able to make decisions based on solid quality information. I said we're going to spend a little less time on service inventories. It's important that we think about it a little differently. Again, inventories in service mean having people ready to deliver that service. We might have supporting inventories. Because service involves the customer, losses may also come from shrinkage or pilferages or theft. and again, we want to do a good job of managing that process. So let's talk a little bit about the types of demand for in inventory. First thing I would cover is excuse me, independent demand. And in independent demand, the demand for an item is independent of the demand for any other item in inventory. So the demand for apples is independent of the demand for Band-Aids in a grocery store. And so we don't have to think about the demand of one when we think about the other. If we have dependent demand, the demand for an item is dependent on the demand for some other item in inventory. So this could be, if you think about a grocery store, the demand for jam is related to the demand for peanut butter, often both, and so we have to think about both when we're forecasting. In production, it could also be the demand for one part is related to the demand for the end product, and so we have to think about if we're making cars, for every demand for a car we have demand for 4 tires, and so that's what dependent demand is, and understanding that becomes important in the planning process. So we have different kinds of inventory costs that we need to think about. The first one is holding costs, the cost of holding or carrying inventory over time. That is the cost of the money that you have held in storing and holding that inventory. It can also include storage costs, but it is the cost actually of owning that inventory. The other two are related, and they are ordering costs, and they're the cost of placing an order and receiving goods. So they are the cost of executing an order and processing an order and receiving an order. So obviously every time we place an order, we have ordering costs. And so we would like, in that circumstance, to have bigger orders so we minimize our ordering costs. But if we have bigger orders, we have bigger holding costs. And so our objective in inventory models is to balance holding costs and ordering costs. The third cost on this page is setup costs. And setup costs are similar to ordering costs, but they are more in a production context. So here you're saying it costs the cost of placing an order and receiving the goods. Here it's the cost of preparing a machine or process for manufacturing an order. So these are similar. We try and balance, again, setup with holding costs, or ordering costs with holding costs. And you'll see that in more detail in the future videos where we talk about that balance in different types of models. We need to determine when and how much to order. Those are key decisions. So I will deal in a separate video with the basic economic order quantity model. That is the foundational model in inventory, and it is probably the one I focus on most in an introductory operations class. We have the production order quantity model, and it is similar, except that it allows us, in an economic order quantity, you order, you get it all at once. In a production order quantity, you have a production rate, you're producing it, so you get to zero inventory and you start to produce, and you're using that inventory as you're producing, then you stop producing and you burn through the inventory going forward. So that is also an important one. And the third most important is a quantity discount model. This model tells us what the optimal one is that completely balances holding costs and setup or ordering costs. Whereas the quantity discount model says, well, sometimes if we order more, we get a better deal, and we need to take into account the acquisition cost in addition to the holding and setup costs. So we'll go through some examples. These are the three most important ones that we'll cover. There are a number of others that I think are worth thinking about. One of those is what's called the single period model, or the news vendor model. And it's when you only place one order for a product. It's usually a perishable product. It's called the news vendor model, because you think about it, in the days when we actually read newspapers, we ordered newspapers and hoped to sell some of them. In this case, we have unpredictable demand. With the EOQ model, we have predictable demand. So we don't know exactly how much we're going to sell. We want to have enough to meet demand, but we don't want to have too much that we have to throw it out. And so, especially if it's a perishable product, so like a newspaper, I can't sell today's newspaper tomorrow. So if I don't sell it today, I have an issue and I lose that. And so yeah, units have little or no value at the end of the sales period. And so in this, we want to balance the cost of running out with the cost of having too much. And so the cost of shortage, very simple, is the lost margin if we don't have it available for sale. So that's the sales price per unit minus the cost per unit. Now, in some businesses, we also have to think about the potential reputational risk of running out. And so we don't just think about the lost margin, we think about the lost future margin. But in most cases, we look at the simplest case where we just look at the foregone margin. And then the cost of overage is what happens if we order too much, and that is the unit cost minus the salvage value. And the salvage value is if we can sell it or we get a credit back from our supplier or whatever. There are sometimes we actually have to add where we have a disposal cost, but we won't talk about that in detail. Then we look at the service level. This is called the critical fractile, where we look at the cost of shortage over the cost of shortage plus the cost of overage. And so the higher that ratio is, the more important the shortage cost is versus the overage cost, the more likely we are to order more. And I have posted already a video on the news vendor model and how we determine the amount to order in this specific case. So this is a very specific single period model for perishable products where we can't carry inventory forward. We already talked about EOQ, POQ, and quantity discount. Those are models in which you order when you hit a specific point. There are also what's called fixed period systems, which I'm going to spend a little bit less time on, but I thought I would introduce here. And in this case, you place orders at the end of a fixed, so you say we are going to place a weekly order, and you count inventory at the end of the period and then decide how much to order, and you order enough to bring you up to a specific target level. And so in this case, the only relevant costs are ordering and holding costs. Lead times are known and constant, and we'll talk about uncertainty in a separate video. And items are independent from one another. And so in that circumstance, you have the target, and each time period, P, we order. So if we take an inventory and we're here, we order this much up to that level. And then our demand gets used over time period P. We then again look, we've got this much, so we order Q2 and get us back up to that level. This time we had high demand, so at the end of time period P, we order up to that level. So in a fixed period system, you don't order the same amount. In the EOQ, POQ models, you order the same amount and you do it triggered on a specific inventory level. Here you order up to a level in every fixed period, whether it's a day, a week, 5 days, whatever, on a regular basis. And the problem with fixed period models is you only count inventory at the specific time. You can do it at convenient times, so that's a benefit. If you have routine predictable demand, that makes some sense. The problem with it is it may result in stockouts between periods, right? You're not tracking your inventory on a regular basis, and if all of a sudden you have a rush in demand, you could get to zero before your time period elapses. So that can cause you some grief. And what it does is it may require it says safety stock. It may require increased safety stock. And safety stock is a buffer of inventory that protects you when demand is uncertain. So you think, well, we're going to sell this many units, but sometimes it's variable, so we're going to have this many units of safety stock to protect us from running out. And in a separate video, I'll be talking about ordering policies and safety stock policies when demand and or lead time are uncertain. And so that's what safety stock is, and we use it to protect ourselves from running out and hurting our customer service levels. So to wrap this up, inventory is important. There are lots of different types of inventories in these 4 broad categories. There are many methodologies for calculating the best sort of just-in-time inventory requirements, and we're going to introduce a few of them. And usually you are introduced to a few of them in an introductory operations management course. We're going to talk about the economic order quantity, the production order quantity, the quantity discount model, the news vendor model. We're going to talk about uncertain lead times, uncertain demand, safety stocks, and reorder points in that circumstance. So this provides you with a quick overview of the concept of inventory. Tune into the other videos to get a good understanding of how what some of these tools are to make inventory decisions. So that's it for now. Thanks. Have a great day.